Hello folks, so we are going to do, let me click on this so it can move, 4.3, which is the writing equations of parallel and perpendicular lines. So here are the main concepts today. Parallel lines, I'm going to read this. Two lines in the same plane, so think of a plane as being like a piece of paper, like a flat surface, that never intersect are parallel lines. So parallel lines never intersect. Two distinct non-vertical lines, that means this can't be vertical like this, are parallel if and only if they have the same slope. So an example of parallel lines would be, here's a line, there's a line. So those are parallel, and we can mathematically determine that they're parallel if they have the same slope. So all vertical lines are parallel, all horizontal lines are parallel to each other. Perpendicular. These are two lines in the same plane that intersect to form right angles. So that's sort of like what we see right here in this picture. And those are perpendicular lines. Non-vertical lines are perpendicular if and only if their slopes are negative reciprocals. Vertical lines are perpendicular to horizontal lines. So I'm going to make a quick, here is a pair of perpendicular lines, and we know they're perpendicular on a graph if you ever see the little right angle sign, but if you don't, we can determine mathematically if they are perpendicular because they have negative reciprocal slopes. So what is a negative reciprocal? So an example would be 3 over 4. The negative reciprocal means you take this fraction, you flip it upside down, and then it's negative. Or let's say I started with a negative 1/2. If I flip that, the 2 goes on top, the 1 goes on bottom, and if this was negative, the new one's positive. And 2 over 1 is the same thing as just 2. So these are some examples of negative reciprocal slopes. So let's get into some examples here. The first example is we need to determine which of the lines are parallel. Find the slope of each line from the graph. So let's look at line A. I'm just going to count my slope. I go down 1, so that's negative 1, and over 1, 2, 3, 4, 5. So this has a slope of negative 1/5. Line B, I go down 1, and I go over 1, 2, 3, 4. So I can tell you right now that line B and A are not parallel because they have different slopes. Let's look at line C. I go down 1, and then I go over 1, 2, 3, 4, 5. So notice how line C and line A have the same slopes. So what I would do here is I would say lines A and C are parallel. There we go. That would be our final answer for example 1. Example 2, write an equation of a line that passes through a point and is parallel to line y equals 2x plus 3. So the first step we need to do is determine what our new slope will be. So I'm going to highlight where it says parallel, and right above it, parallel means the same, which means I need to find the slope of 2x plus 3. Well, this is already in y equals mx plus b form, so my slope is this 2. So I'm going to write down the m equals 2, and I'm going to write down the point they gave us. They want us to use the point 5 comma negative 4, and now we go right into our point slope form. So I'm going to say y minus negative 4 equals 2 times x minus 5. Double negative makes a plus. Now I'm just going to solve for y. And so I'm going to get y plus 4 equals, when I distribute, I get 2x minus 10. Subtract 4 from both sides, and I get y equals 2x minus 14. So there's my answer. And if I wanted to check these, I'm going to bust open my calculator here, make it where you can see this. Here we go. If I want to check these, I could go to my graphing calculator and type these in the y equals. I'm going to type in the y equals 2x minus 14, and then I'm going to type in on the other line the 2x plus 3, and notice both of these have a 2 in front of the x, so they do have the same slope, but when I graph these, hopefully, when I hit graph, they will look like they're parallel. There's one of them, and the next line. They look pretty parallel to me. You could zoom out to double check that, but that looks pretty good. So now let's go to, there's an on your own here. And there's an on your own number 2. For the sake of our notes online, I'll go ahead and let you do these and then I'll explain them, okay? So go ahead and do those. You can pause it and then try them. All right, now that you're back, I'm going to figure out the slope of line A. So that's going to be my slope formula. So when you did this, hopefully you got 4 over 1, which is 4 for line A. So line A has a slope of 4. Line B, negative 2, 3, negative 7, 2. I'm going to get, that's going to be 5 over 1. So they are not parallel. For on your own number 2, write the equation of that line. That's parallel. So I want to use the same slope, which is 1/4. So I should write y minus 2 equals 1/4 x minus negative 4. Make that a double. And when you do your distributive property, you would have got 1/4 x plus 1. And when you added the 2, you should have got y equals 1/4 x plus 3. So there's that on your own number 2. Let's go to example number 3. Determine which of the lines, if any, are parallel or perpendicular. So first we need to write all of our equations into y equals mx plus b, slope-intercept form. And then we can easily find the slope. So line A is already that way. Line B, we have to rewrite this. So let's subtract the x from both sides. So I get 4y equals negative x plus 3. Divide everything by 4. So I get y equals negative 1/4 x plus 3/4. And then, same thing over here, let's add the 2x. So I get negative 8y equals 2x plus 16. Divide everything by the negative 8. And I get y equals negative 1/4 x minus 2. So, parallel means same. So let's find the ones that are parallel. The parallel lines, notice I have a negative 1/4 slope and a negative 1/4 slope, and over here I have a positive 4. So I know that lines B and C are parallel. Let's talk about perpendicular. So I first want to make this a fraction, the first one. Notice that all my slopes have a 4 and a 1. This one's a positive, and these two are negative. This is a 4 over 1. These are 1/4. So line A is perpendicular, or has the negative reciprocal to lines B and C. So lines that are perpendicular, A and B are perpendicular, and A and C are perpendicular to each other. All right, let's look at example 4. Write an equation line that passes through this point, negative 3, 1, and is perpendicular, which means we need to find a negative reciprocal slope to the line y equals 1/2 x plus 3. So determine the new slope. So if the original slope is 1/2, the negative reciprocal means I'm going to flip that to be 2 over 1. And if this is positive, this is negative, which is just negative 2. So I want to use a negative 2. So I'm going to use a slope of negative 2, and then the point negative 3 comma 1, and now we go into our point slope form, which is y minus 1 equals negative 2 times x minus negative 3. That's a double negative. Let's go ahead and do our distributive property, which gives me negative 2x when I go here, and then I get negative 6. I'm going to add 1 to both sides, and I get y equals negative 2x minus 5. There we go. That is my equation. I'm going to double check what this will look like using my graphing calculator. So I'm going to go over here, go to my y equals, and clear these out. I'm going to type in my original equations. Negative 2x minus 5, and then the other one was 1/2. So 1/2 x plus 3. I'm going to graph these and see if it looks like they are perpendicular. Now, it might not look like it to you. Remember, this is scaled really weird. So if you're testing for perpendicular, what you can do is you can go to zoom and go down where it says square. If I press enter, now these are spread out the correct way, and now it should look, there we go, it looks nice and crisp. There we go. So these are just a little visual to help you see that they are perpendicular. All right, so that was example 4. Let's see what's, all right, there's some on your owns here. For the sake of the notes, I'm going to just skip these now, just for the time, and let's do example 5. The position of a helicopter search and rescue crew is shown in the graph. The shortest flight path to the shoreline is one that is perpendicular to the shore. Write an equation that represents this path. All right, so we want to find an equation that represents this path right here, this red path. Now there is a point here, so I'm going to write this so I know a point. Now I need to find the slope of this. Now I don't want to just count the slope of this right here because I mean you could find another point on here, and let's just double check this. I guess we could do this. We can go down, sorry, we're going up 1, 2, 3, and then over 2. So 3 over 2, we think it's 3 over 2, but let's just make sure that's perpendicular to the shore. So I'm going to find 2 points on the shore. The shore, it helps if I can find another point. Here's a point right here. And then here's a point right here. So I go down 2 and over 1, 2, 3. The negative reciprocal of negative 2/3 is 3 over 2. Okay, so since they gave us that line and it is accurately done, awesome. So we have a point, we have a slope. We're just going to go right into y minus 4 equals 3 over 2 times x minus 14. Do our distributive property to get 3/2 x. If I go here, that's going to be a negative 21. Add the 4. We get y equals 3/2 x minus 17. And there is the equation that represents this red line here. All right. The only difference with this next one is they're talking about traveling parallel and going through that point. So if you know that the slope of, I'm just going to write down the points and then you can do this on your own. This is going to have a slope that's parallel to the shore, which means you're going to use the same slope, which is negative 2/3, and you're using the point 9, 3. So then you can finish this, but the point slope form would be y minus 3 equals negative 2/3 times x minus 9. You know what, why don't I just finish this, because it won't take long. Y minus 3 equals negative 2/3 x. So if you multiply this, it's going to be a plus, and that's going to be a 6. Add 3 to both sides, and you get y equals negative 2/3 x plus 9. All right, there you go. So if you did that one on your own, you can check those answers. All right, I'm going to stop. This was a long thing of notes, but that's all right because you're all awesome. If you need any help, just reach out and ask. All right, see you here next time.